Now let's see the negative clock skew impact. So first of all, we have to understand how we are calling it as a negative clock skew. So this is our launch flow, and this is our capture flow. And if you see here, the clock is first coming to capture flip-flop, and then there will be some T skew or clock skew, some delay will be introduced, and then the clock will reach to the launch flip-flop. So if you see here, the capture flip-flop will get the first clock, and then after some T skew time, the launch flip-flop will get the clock. But the data is always launched by the launch flip-flop and it is captured by the capture flip-flop. So if you see here, the data direction is from left to right, but the clock direction is from right to left. So the clock skew, which is introduced by the delay elements between the clock of capture flip-flop and launch flip-flop, is nothing but called negative clock skew. If you see through the waveforms, this is clock 1 and this is clock 2. So clock 2 first the clock 2 will, the rising edge is happening, and after the T skew time, the clock 1 rising edge is happening. So basically data is always launched at this flip-flop, and now when it will get captured, this data will get captured at this clock edge. So this is launch and this is capture. And now when the hold check will be happening, the hold check will happen at this clock edge. So here this is the data, and here this is the setup check, right? So now if you see here, the T skew is basically now coming from capture flip-flop towards the launch flip-flop, this direction. So this is called nothing but our negative clock skew. So in other words, if you say here, if you see data is launched at this clock edge and it is captured at this clock edge. So what happens is the time between the data launch and data capture has actually decreased by T skew time. So if the data time between launch and capture flip-flop has decreased, this is basically required time. So here if you see, the required time has decreased. We will see in the next slide how the negative clock skew will impact the setup and hold timing equation. But in this slide, let's concentrate on what is negative clock skew. So hope this is clear. So the negative clock skew is basically when the data and clock directions are in opposite direction. And how the setup and hold check will happen in this case? The setup check will happen at this point, and the hold check will happen at this time. So the hold check is happening actually before the T skew clock time. Okay. So this is the hold check. Ideally, the hold check happen at the same clock edge. So if there is no clock skew, the clock 2 rising edge would have happened here, but it is happening now before the T skew. So the hold check will happen before T skew time. Okay. Now let's see the impact on setup equation. So here the T skew is always less than 0. It is negative. Now let's see the effect of this on the setup equation. So ideally speaking, if there is no clock skew, just remove this T skew, this term, and we have the clock to Q delay plus combinational delay should be less than clock period minus T setup of register 2. But now the T skew, negative T skew has come here. So now this time, this term, what this term will become? So what this equation is saying, this delay should be less than this clock path delay. So this is the clock path delay. So the data is launched at this clock edge, and now ideally at this clock edge minus setup time. That was the term corresponding to this. Correct? Now because of the negative skew, actually the capture rising edge has shifted towards left by T skew time. Correct? Now we have to meet this requirement in T skew time less. So here we have put minus T skew. So this minus T skew has taken care of the T skew is less than 0. So what we don't have to put the extra minus here. we already have taken care of minus negative clock skew by subtracting the t skew time. So just visualize it and just understand that now the required time, actually the required time in ideal case, the required time was clock period minus t setup, but now the clock edge itself has shifted left by t skew time. So now the required time has basically decreased. So now the clock period, if we rearrange this equation, clock period has increased by t skew time. So if clock period increases, our frequency decreases, and if our frequency decreases, that means our design can now only work at lower frequency, right? So if you see the required time, so now the required time has decreased by the t skew, and arrival time is again going to be the same. Now the setup slack will become required time minus arrival time. So required time has decreased. So if the required time has decreased here, that means our setup slack will also decrease. So negative clock skew basically degrades the performance of our design. Always remember that with negative clock skew, our required clock period to meet the setup requirement has to be increased by the t skew time, and hence the frequency of operations will decrease. So always remember, positive clock skew improves the performance of our design. That means our design can work at higher frequency, but negative clock skew degrades the performance.